So in this video we're going to come up with the matrices that we need to cause x and y axis reflections to occur. So what we want to think about is what happens when we do an x or y axis reflection. So suppose I have a vector sitting here and he's the vector u equal to, let's say he's negative 2, 3. So he's negative 2 units over, 3 units up. If we wanted to reflect this vector in the x-axis, so reflection in the x-axis would look something like this. And what we want to recognize is that to reflect him in the x-axis, so I'm going to call it u prime because he's been transformed. This prime notation again denoting the transformed vector. So if I want to reflect in the x-axis, that's just simply a matter of taking and keeping the x-coordinate the same. If it's negative 2, we're still going to be over at negative 2, but negating the y-coordinate. So when we see a transformation like the one right here, where the y-coordinate has been negated, that is simply an x-axis reflection. Similarly, if we wanted to do a y-axis reflection, so let's reflect this vector in the y-axis, we note that the y component stays the same, so I'm going to call this u sub 2 prime, the second transformed version of the original vector u. And to get this y-axis transformation, or reflection, sorry, we would simply take and negate the x-coordinate. So this is a negative 2, would need to become positive 2, but the y-coordinate would need to stay the same. So an x-coordinate negation is simply a reflection over the y-axis. So the other thing that we want to recognize is that if we have, for example, this y-coordinate negation, which is causing a reflection over the x-axis, we could reimagine this transformation like this. We could say, hey, this is one, in the first row I have 1x plus no y's, and in the second row I have no x's. In this, whoops, went crazy with the eraser right there on accident. So in the second row we have no x's and we have minus 1y. And what we want to recognize is then that this could be represented in matrix form, which we've done before. We could say this is a 1, 0, 0, negative 1 times xy. So this matrix right here will, when we do the dot product, 1 times x plus 0 times y will give us our x. 0 times x minus 1 times y will be the opposite of y. This matrix here has the same effect of just directly negating the y-coordinate. So this gives us a transformation matrix then that is a x-axis reflection. And similarly, if we wanted to, this matrix, this negative xy, or sorry, this transformation, this y-axis transformation, we could get this transformation in matrix form by doing negative 1, 0, 0, 1, and multiplying by x, y. So we do negative 1 times x plus 0 times y is the opposite of x, and 0 times x plus 1 times y is y. So this matrix right here causes a y-axis reflection. So these are the two matrices that we put in our pocket. Transformation matrix for y-axis reflection, transformation matrix for x-axis reflection.